This is a question. A healthy young man standing at a distance 7 meter from a 11.8 meter high building. So the height of this building is 11.8 meter, and a young man is standing at a distance 7 meter from the building. Sees a kid slipping from the top of the floor. So a kid is slipping from the top of the floor. With what speed should he run to catch a kid at his arm's height? Arm's height means that is given 1.8 meter. So this height is 1.8 meter. So he has to catch at this height. So how much height the kid will fall? So he will fall 11.8 minus 1.8 meter. So he is going to fall by a distance 10 meter. So 10 meter distance he is going to fall, and in the same time the person, the young man, should run or should cover a distance of 7 meter towards the building. So first we will find how much time the kid takes to fall. So for that we will write S equal to half gt square, because there is no initial speed, no initial velocity. S is 10. Sorry, this is not S. This is total height. S is 10 meters. This is S. So S is 10 meters. Half G we can take as 10 and T square. So if we solve it, the T is going to be how much? Root 2. So in this much time, the kid will fall, and in the same time, the person should be able to run towards the building. So the speed, if you write for the person, that will be 7 meter divided by root 2, which is equal to how much? 7 into root 2 by 2, which can be written as 7 into 1.4, or we can say it 9.8 by 2, or 4.9 meter per second. So this much should be the speed. If you solve it, you are going to get like this. So 4.9 meter per second. If he runs with a speed 4.9 meter per second towards the building, he will be able to save the kids. He will be able to save the. He will be able to catch the kid. Okay. Next topic we are going to see is symmetry in vertical motion. So what kind of symmetry we have? So if you have, suppose, an object, if it is going up and then it is coming down, so what are the different symmetry we are already doing? The time for upward journey is same. So if this time is T1 and downward time is T2, then T1 equal to T2. That is one symmetry. Then from the highest point, how much it will fall in 1 second? In 1 second it is going to fall. That will be how much? That will be half G into 1 square. So that we can write as, in 1 second it is going to fall half G into 1 square. So that will be 10 by 2, so 5 meters. In 2 seconds it is going to fall how much? In 2 seconds it will fall half G into 2 square, that will be 20 meters. So that we have seen last class only. And before this highest point, if you consider 1 second before the highest point, again this remains the same. So again this is 5 meter. So from highest point, 1 second forward or 1 second backward, both sides you are going to have 5 meter distance traveled. If you consider 2 meter backward, 2 seconds backward, again you are going to have the 20 meter. The whole distance before reaching the highest point, 2 seconds before reaching the highest point will be what? 20 meter behind the highest point. So the path is symmetrical on two sides. On one side it is 5 meter after the highest point, and 1 second before it is 5 meter, and 2 seconds after the highest point and 2 seconds before the highest point, again it is 20 and 20. Similarly, 3 seconds after and 3 seconds before, you can write 45 meter and 45 meter. So you can see the both sides, from the highest point, the forward from the highest point and backward from the highest point, for both sides you are having symmetrical paths.